Hello students, in today's lecture we are going to learn about laws of motion NCERT section 4.10 and 4.11 plus example 4.12. Disclaimer: the images, text and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the content immediately. Please note that parts of the content may have been generated using generative AI, which is experimental. Learning objective: by the end of this lecture, you will able to understand the concepts of motion of a car on a banked road and action-reaction pairs. So in today's lecture, we will cover 4.10 circular motion, motion of a car on a banked road. After that, 4.11 solving problems in mechanics, example 4.12. Then action reaction pairs. So these are the topics of the today's lecture. So in today's lecture we will cover the maximum speed of a car on a banked road. Now here question arises, how we can define banked road. Look at figure 4.14. This shows the banked road. Bank road means a bank road is a curb road where the outer edge is raised above the inner edge. So here the inner edge is this one and outer edge is this one. Outer edge is raised above the inner edge. This incline or banking, this in the inclination with angle theta, this incline or banking helps vehicles safely navigate the turn by providing the necessary centripetal force. It means here the theta we know here this is a inclination angle and this helps vehicles safely navigate the turn, and the force is centripetal force. So due to centripetal force, a vehicle can safely turn on a circular path, or we can say on a banked road. So this is the illustration of the banked road where outer edge is raised above the inner edge. So here the theta known as bank angle or angle of banking, this is the theta, the angle at which road is inclined. This angle theta, here the road is inclined, known as angle of banking or bank angle. One important factor, that is friction here. The friction, the force that opposes the relative motion of the surfaces in contact, means road and the between the road and tire. So this is the frictional force. On a banked curve, friction between the tires and the road helps the turning. It means frictional force is a frictional force helps with turning. It means it is an important factor on a banked road. So this is a responsible for the turning point on a curve path. So next, normal force. The normal force represented by N. This is This is the normal force. The force exerted by the surface that is perpendicular to the surface. Here N, look at figure 4.14, N is the perpendicular to the surface. In the case of banked curve, the normal force has both vertical and horizontal components. We know normal reaction, there is a two components. First is the horizontal component, second is the vertical component. If we talk about the horizontal component, so here the horizontal component is N sin theta, and second one is vertical component N cos theta. N cos theta when we resolve the normal reaction. Here theta is the angle of inclination, or we can say bank angle. So when we resolve N, so two vertical and horizontal components of normal reaction is N sin theta and N cos theta. Clear? So another factors, if we talk about a bank road, so let's see maximum speed of a car on a bank road. Now we will drive the equations for maximum speed. Now consider here a vehicle of mass m. So suppose we have a vehicle and the mass of the vehicle is m, and this vehicle is moving with speed v on a banked road. We know what is bank road, we already told you or learnt it. So the speed is v and the radius is, here we consider capital R. So let theta be the angle of banking, or we can say bank angle with frictional force F. This is F, small f is the frictional force that is acting between the tires and road of the, acting between the road and the tires of the vehicle. So this is the illustration. The weight is that is acted vertically downward mg, and the normal reaction n, and the components of the normal reaction n sin theta and n cos theta. So next, maximum speed of a car on a banked road. So since there is no acceleration along the vertical direction, because there is only two forces, F cos theta and N sin theta. This is responsible for circular path, and that provides the centripetal force. So we know there is no acceleration along the vertical direction, so total upward force is equal to total downward force. So the total upward force, look at figure 4.14, a banked road. So upward force is N cos theta, look at it, N cos theta, and total downward force is F sin theta and mg. So we can say the total upward force is N cos theta, which is equal to total downward force, which is mg plus F sin theta, as shown in figure 4.14. Now here N cos theta, one of the components of normal reaction, we already learnt it, along the vertical axis. Second component is mg. This is the weight of the vehicle, and that is acting vertically downward. So here the vertically downward two forces present, F sin theta and mg, which is downward force. So next, let's see. We know this is illustration of a bank road. So the centripetal force is provided by the horizontal components of N and F. So look at here, there is a vertical components and horizontal components of the forces. So if we talk about the normal reaction, that is n, so the vertical component is n cos theta and the horizontal component is n sin theta. And if we talk about the frictional force, so horizontal component is f cos theta and vertical component is f sin theta. So here f cos theta and n sin theta is the responsible for the motion of a car on a bank road, and these two forces provided the centripetal force provided by these two forces, f cos theta and f sin theta. So we can say here n sin theta and sin theta, look at here, horizontal forces, horizontal component of the forces, n sin theta plus f cos theta is equal to mv square by r. Here mv square by r is the centripetal force. So we know f cos theta or n sin theta is the responsible for the circular motion. So that is equal to mv square by r. N sin theta, here one of the components of the normal reaction along the horizontal axis, and the second factor, that is f cos theta, one of the components of the frictional force along the horizontal axis. So along the horizontal axis there is a two forces, we already know, first f cos theta and second n sin theta. Now using the horizontal and vertical components of the forces, we can drive the maximum speed of a car on a bank road. Vmax is the maximum speed of the car. So we have two equations. First, n cos theta is equal to mg plus f sin theta, and the second equation, n sin theta plus f cos theta equal to mv square by r. This one, n sin theta and f cos theta, is the this acts along the horizontal. So thus to obtain Vmax, maximum velocity speed, or we can say maximum velocity of a car on a banked road, we put f is equal to mu s n. So in the equation 4.19a and the equation 4.19b, substitute the value of f. F is the frictional force, that is equal to mu s into n. So when we substitute the f equal to mu s, the equation will be changed. So then equation 4.19a and 4.19b become n cos theta equal to mg plus mu s n. Here we substitute the f is equal to mu s n. So it will be mu s n sin theta. So this equation become 4.20a. And the second equation become, when we substitute f is equal to mu s n, so it will be n sin theta plus mu s n cos theta, which is equal to mv square by r, or we know mv square by r here is the centripetal force. Yes or no? So now using these two equations 4.20a and 4.20b, we will solve maximum speed of a car on a banked road. So solving for n from equation 4.20a. So equation 4.20a is this one. So n cos theta is equal to mg plus mu s n sin theta. This is equation 4.20a. Now using this, we will find the value of n. N is the normal reaction. So n cos theta minus mu s n sin theta is equal to mg. When we replace the terms, so here look at here, n cos theta minus RHS side is mg and mu s n sin theta. When we replace RHS side, that is mu s n sin theta in left side, so it will be n cos theta minus mu s sin theta, which is equal to mg. The remaining term is mg. So here n cos theta minus mu s n sin theta. The common thing is n is common. So take n common, you will be get n cos theta minus mu s sin theta, which is equal to mg. Now we have to find the n. So n will be this one, n equal to mg divided by cos theta minus mu s sin theta. So this is the normal reaction in the form of mg and sine cosine term. And this is important equation. This is the normal reaction. Clear? So we have n equal to mg cos theta minus mu s sin theta. Yes or no? We already calculated it. So cross multiplying or this is n, and the another equation, that is n sin theta plus mu s n cos theta equal to mv square by r, that is responsible for the motion on a bank road. Yes or no? So substituting the value of n in equation 4.20b. So n equal to this one, mg divided by cos theta minus mu s sin theta. So now just substitute the value of n in this equation. So you will be get a new equation. So it will be mg into sin theta plus mu s cos theta after substitution. So mg sin theta plus mu s cos theta divided by cos theta minus mu s sin theta, which is equal to mv square max divided by r. Just this become after the substitution. Now using this equation we will find the v max, that is maximum speed of a car on a banked road. So now solving further, solving for v square max, maximum speed of a car on a banked road. So it will be mg sin theta plus mu s cos theta divided by cos theta minus mu s sin theta, mv square max divided by r. We know this equation. So multiplying both side by r. When we multiplying both side by r, the equation is this one, r into mg sin theta plus mu s cos theta divided by cos theta minus mu s sin theta and mv square max. R here cancel out. The remaining term is this one. Now further divide both side by m. So after division it will be rg sin theta plus mu s cos theta divided by cos theta minus mu s sin theta, which is equal to v square max after division. When we divide both side by m. So equation will be this. So by dividing numerator and denominator by cos theta in equation this one, rg sin theta plus mu s cos theta divided by cos theta minus mu s sin theta, which is equal to v square max. So after dividing numerator and denominator by cos theta, the equation is this one, rg sin theta divided by cos theta plus mu s cos theta divided by cos theta and whole divided by cos theta divided by cos theta minus mu s sin theta divided by cos theta is equal to v square max. This equation become when we divide numerator and denominator by cos theta. Clear? So we know sin theta upon cos theta is tan theta. So we here substitute. And cos theta cancel out, the remaining term is mu s. And cos theta cancel out, the remaining term is 1. Minus mu s sin theta upon cos theta is tan theta. So it will be rg tan theta plus mu s divided by 1 minus mu s tan theta equal to v square max. So this is the maximum speed of a car on a bank road. Therefore, we can say V square max, that is maximum speed of a car on a bank road, is equal to Rg mu s plus tan theta divided by 1 minus mu s tan theta. So this is the maximum speed. Clear? Here the R is the radius, R is the radius and G is the acceleration due to gravity. Before starting the derivation of a maximum speed of a car on a bank road, we consider R is the radius and G is the acceleration due to gravity. And we dividing numerator and denominator by cos theta in this equation because we want simplicity to find out the maximum speed of a car on a bank road. So that's why we choose dividing method. So V square max is equal to Rg into mu s plus tan theta divided by 1 minus mu s tan theta. So this equation become now, but we have to find out the V max, not V square max. We have to find out the V max. So further solving this equation, we will get a new equation. And so we have V square max, that is V square max is equal to Rg mu s plus tan theta divided by 1 minus mu s tan theta. So this is the square of maximum speed. Take the square root of both sides, we will get V max. So that is V max is equal to Rg mu s plus tan theta divided by 1 minus mu s tan theta whole power 1 by 2, or we can say under root Rg into mu s plus tan theta divided by 1 minus mu s tan theta. So this is the maximum speed of a car on a bank road, and this relation is a very important for the exam. If we talk about the bank road, the maximum speed is this one. So we have V square max, that is this one. V max is equal to under root Rg mu s plus tan theta divided by 1 minus mu s tan theta. This is the V max. So we know in the case of motion of a car on a level road, the maximum speed of the circular motion of the car is this one. V max is equal to under root mu s Rg. Listen carefully, there is a two important point. First, if we talk about the maximum speed of a car on a level road, the formula is V max is equal to under root mu s Rg. And if we talk about the maximum speed of a car on a bank road, the formula is this one. V max is equal to under root Rg mu s plus tan theta divided by 1 minus mu s tan theta. So both are the maximum speed for the different cases. 4.21 for the car on a bank road and 4.18 for a level road, flat road. Got it? And both important, both equation 4.21 and 4.18 are important. So now when we comparing the equation 4.21 and with equation 4.18, this is clear that we see that the maximum possible speed of a car on a bank road is greater than that on a flat road. Look at here, Rg here is the common, the remaining term is mu s plus tan theta divided by 1 minus mu s tan theta. This term is extra and both having square root. So we can say maximum possible speed of a car on a bank road is greater than flat road. So maximum speed of a car on a bank road, that is V max is equal to under root Rg mu s plus tan theta divided by 1 minus mu s tan theta. So if we put mu s is equal to 0 in equation 4.21, this is equation 4.21. So the equation become V naught equal to Rg tan theta whole power 1 by 2. just substitute the value of mu is equal to 0. You will be get equation 4.22. At this speed, frictional force is not needed at all the provide necessary centripetal force, because the coefficient of static friction is 0. So we can say frictional force is not needed at all to provide the necessary centripetal force. For a this is the important condition. For a car parked on a bank road to remain stationary without slipping, the condition is tan theta is less than equal to mu s. This is the condition for the without slipping when a car is parked on a bank road, and this relation is very important, so remember this. Now next one is solving problems in mechanics. Now here again a question arises, how we can understand the concept of solving problems in mechanics. Basically, solving problems in mechanics involves a systematic approach to analyzing and resolving physical situations involving forces, motion and energy. So this is the concept of solving problems in mechanics. So to solve problems in mechanics, there is some steps. So we can say to handle a typical problem in mechanics systematically, one should use the following steps. And these steps are, first is draw a diagram showing schematically the various parts of assemblies of bodies, the links, supports, etc. It means firstly draw the diagram schematically. This is the first step. The second step, choose a convenient part of the assembly as one system. So second is the choose a convenient part. Next step, we can say third step, draw a separate diagram which shows this system. If the in a system there is a so much diagram, and we can say the diagram is more than 2 and 3, so you need to separate them. So all the forces on the system by the remaining part of the assembly, and include also the forces on the system by the other agencies, like we already learned the components of the normal reaction, that is n sin theta and cos theta. Similarly, resolve the forces. Do not include the forces on the environment by the system. And a diagram of this type is known as free body diagram. It means the resolving the all forces factors of a diagram, or we can say of a system, known as free body diagram. So next step is, in free body diagram, include only known forces with their given magnitudes and directions. Include known directional forces like tension along the string, or we can say frictional forces, that is we already learned, that is f sin theta and f cos theta. And mark all the forces as unknowns. Use these knowns to find unknown using motion laws. And next step, if necessary, follow same procedure for another choice of system. Clear? This one is some steps to handle a typical problem in mechanics in mechanical system. Clear? Now to understand these steps is uh, we will take an example. So read example carefully. A wooden block of mass 2 kg rests on a soft horizontal floor. It means we have a wooden block and the mass of the wooden block is 2 kg. That is in a rest condition on a soft horizontal floor. When an iron cylinder of mass 25 kg is placed on top of the block. Look at here. When a iron cylinder is placed on a block, the floor yields steadily and block and cylinder together go down with acceleration of 0.1 meter per second square. So this is the given acceleration. And the mass of the iron cylinder is 25 kg. So question asked about the what is the action of the block on the floor? A. Before and B. After the floor yields. Take G equal to 10 meter per second square. Identify the action reaction pairs in this problem. Also you have to find out the action reaction problems. So we will solve this question and understanding the action reaction pairs also. So think about it. We will solve this question step by step. First, we will find the action of the block on the floor before, after that action of the floor after the floor yields. After that, we will identifying the action reaction pairs in this problem. Clear? So, solution. If we talk about A part, so initially the block having mass 2 kg having at rest condition. So its free body diagram shows two forces on the block. Yes or no? The block is at rest on the floor. So in that case, there is a two forces on the block. Which one? First force, we can say the force of gravitational attraction by the earth, that is equal to 2 into 10, which is equal to 20 Newton, or we can say weight, mass into G. So here G is 10 meter per second square and mass is 2 kg. So the force of gravitational attraction is 20 Newton. This is the first force. And the second force is the normal force of the floor on the block. Normal force R. Now here the important thing is this. What is the direction? The direction of the weight is vertically downward and the direction of R vertically upwards. So by the first law, the net force on the block must be 0. Yes or no? So R equal to 20 Newton. Using third law, the action of the block, the force exerted on the block by the force exerted on the floor by the block is equal to 20 Newton and direction vertically downwards. Direction is vertically downward. So let's see further calculations. So we can say here the system of block plus cylinder. In the second case, the mass is increases. The mass of block plus mass of cylinder that accelerates downwards with speed, acceleration 0.1 meter per second square. The free body diagram of the system shows two forces on the system. If we talk about this body, this system, there is a two forces again. Yes or no? So first is the force of gravity due to earth, that is 240 Newton. 240 Newton. This is clear? Because here the mass is 25, mass of this iron cylinder 25 plus mass of the block 2 kg. So 25 plus 2 equal to 27 kg. So, and the weight acted vertically downward. So mass into g. The value of g is 10. So it will be 227 into 10 is equal to 27 Newton. And the normal reaction R prime by the floor, and that is acted vertically upwards. So from this diagram, first condition and second condition, this is clear that the action and reaction, action that is vertically downward and reaction vertically upward. Clear? So applying the second law to the system, net force is equal to mass of the block plus mass of the cylinder into A. A is the acceleration. So look at figure 4.15. Here the weight that is acted vertically downward. So 270 minus R equal to net force. So net force is mass of the block, that is 2 kg, plus mass of the cylinder 25 kg into A. So solving this, you will get 270 minus R prime equal to 27 into A. A is the acceleration that is given in this question, 0.1 meter per second square. So solving this, you will get R prime equal to 267.3 Newton. So this is the reaction. Clear? So by the third law, the action of the system on the floor is equal to 267.3 Newton vertically downward. So next is action reaction pairs. For A means before and B means after floor yields. So for A, the force of gravity 20 Newton on the block by the earth. So we can say this is action. And the force of gravity on the earth by the block, this is called reaction, that is equal to 20 Newton and directed upwards. The force on the floor by the block, that is action, and the force on the block by the floor, that is reaction. Here we neglect the forces by the surfaces. So if we talk about B, the force of gravity, that is 270 Newton on the system by the earth. So here we can say action, and the force of gravity on the earth by the system called reaction, that is 270 Newton. And the direction is directed upwards. Second, the force on the floor by the system is action, and the force on the system by the floor is reaction. So this is the terms of action and reactions, and the combination of action reaction we called action reaction pairs. Clear? Now summary. Now we will summarize. A bank road is a curved and tilted inward to help vehicle turns safely. Banking angle helps providing the necessary centripetal force. No friction is needed in an ideal banked road where mu is equal to 0. Maximum velocity on bank road, this one, Rg into mu s plus tan theta divided by 1 minus mu s tan theta whole power 1 by 2. Action force, this is the initial force exerted by one object on another. Reaction force, this is the force exerted by the second object back on the first object in response to action force. Clear? Now we have some practice questions for you. First question, question is a car travels on a bank circular road of radius 100 meter at a speed of 20 meter per second. If the coefficient of friction is 0.2, what is the minimum banking angle required to prevent sliding? In this question, you have to find out the minimum banking angle. And second question, two masses m1 equal to 3 kg and m2 equal to 5 kg interact through a spring on a frictionless surface. If m1 experiences a force of 12 Newton to right, what is the magnitude and direction of the force experienced by m2? So in this question, you have to find out the magnitude and direction of the force experienced by m2. Third question, a car of mass 1500 kg travels on a bank road, bank curve at 25 meter per second. If the radius of the curve is 200 meter and the banking angle is theta equal to 15 degree, what is the normal force exerted by the rod on the car? Here you have to find out the normal force. And next question, a motorcycle travels on a banked curve with angle theta. If the coefficient of friction mu is equal to 0.3 and the speed is v equal to 15 meter per second, find the minimum speed of the curve for which the motorcycle can travel without slipping when theta equal to 20 degree and take g equal to 9.8 meter per second square. Clear? So this is practice questions for you. Thank you for your attention.